Hello everyone, in this video we're going to review limits, continuity, and differentiability of AB, calculus AB, and BC. First, we're going to review the following concept. Number 1, the existence of a limit. A function f(s) has a limit L as s approaches C if and only if limit of the function f(s) when s approaches C minus equals limit of the function f(s) when s approaches C plus, right? Now, number 2, we're going to talk about the continuity. A function is continuous at a point s equals a if and only if f of a exists. Limit of f of s when s approaches a minus equals limit of f of s when s approaches a plus. Limit of f of s when s approaches a equals f of a. Number 3, we're going to talk about the limit definition of a derivative. So we have f prime of s equals limit of f of s plus h minus f of s over h when h approaches 0. Or we have another form, it's going to be f prime of a equals limit when s approaches a of f of s minus f of a over s minus a. Now number 4, we're going to talk about the continuity and differentiability. A function is differentiable at a point, then it is continuous at that point. If the function continuous, then it may not be differentiable. We're going to talk about the L'Hospital rule. If the limit of f of s over g of s when s approaches a has the indeterminate form 0 over 0, infinitive over infinitive, negative infinitive over infinitive, infinitive over negative infinitive, or negative infinitive over negative infinitive, then the limit when s approaches a of f of s over g of s equals limit when s approaches a, you're going to take derivative of the numerator and derivative of denominator. Alright, now we're going to go to the number 1. Calculator not allowed. We need to find the limit of 4n squared over n squared plus 10,000n. Alright, so when n approaches infinity, we're going to use the relative growth rate. This guy right here grows faster than this guy, right? So we can ignore this guy, right? So this guy becomes limit when n approaches infinity of 4n squared over n squared, right? This guy cancel out. The answer is 4. The answer must be D. Now let's move on to question 2. The limit of tangent 3 times s plus h minus tangent 3s over h when h approaches 0 is what right here? So we look at the formula right here. It's actually this form right here, right? So we can identify the function f of s, right? So this guy and this guy match, right? So we can conclude that f of s equals tangent 3s, right? And remember, this guy right here actually f prime of s, right? Look at this one right here. So we're gonna take f prime of s equals, we're gonna use the formula tangent u prime. It's gonna be u prime secant square u, right? So this guy becomes 3 secant square 3s, right? So the answer must be B. Now question 3. We need to find the limit of 7s minus sine s over s squared plus sine 3s when s approaches 0, right? So we're going to substitute 0 for s to see what happens, right? So we have limit of 7s minus sine s when s approaches 0, right? So it could be 0. Limit of s squared plus sine 3s when s approaches 0 is still 0. So we have the indeterminate form 0 over 0, right? So we say the L'Hospital rule apply. So it's going to be limit when s approaches 0. Take the derivative of this one to be 7 minus cosine s over 2s. Sine u is going to be u prime times cosine u, right? So it could be plus 3 cosine 3s, right? Now substitute 0 for s, it could be 7 minus cosine 0 is could be 1 over 2 times 0 could be 0, and then it could be 3 cosine 0 it could be 1, right? So like that. So it could be 6 over 3, it could be 2. The answer must be B. Now question 4. We need to check to see if the function is continuous at s equals 3, right? So we have f of 3, right? So we see the equal sign right here, right? We need to use this one. So it could be 6 times 3 minus 9. It could be 9, right? Now we need to find the limit of the function f of s when s approaches 3 minus, which is this guy right here, right? So it could be 3 square, it could be 9. And limit of f of s when s approaches 3 plus, right? So it could be this guy right here. 6 times 3 minus 9. It's going to be 9, right? So we see that limit of f of s when s approaches 3 is it, right? Because the left and the right the same, right? And then we have the limit of f of s when s approaches 3 equals f of 3, and they both equals 9, right? So then the function is continuous at s equals 3, right? Now we're going to check to see if the function is differentiable, right? So we need to take the derivative of this one, right? So I have f prime of s equals derivative of this one could be 2s for s less than 3 and 6 for s greater than or equal to 3, right? Now in order to check for the differentiability, we need to find the limit of the function f prime of s when s approaches 3 minus, right? It's going to be this guy right here. 2 times 3 is going to be 6. And this guy actually equals the limit of f prime of s when s approaches 3 plus, which is this guy right here, equals 6, right? So then you can conclude that the function is differentiable. So the answer must be E. Question 5. The figure above shows the graph of a function f with the domain 0 to 4. Which of the following statements are true? Number 1. Limit of ls when s approaches 2 minus is this. Alright, so 2 minus, which means this guy right here. Right? So we're going to pick this guy right here. Yes. Right? Limit of ls when s approaches 2 plus, which means 2 to the right, right? Which is we're going to pick this guy right here. Yes. Right? Limit of ls is it when s approaches 2? No. Right? Because this guy right here equals something right here. For example, I'm going to say 2. And this guy right here is going to be 1, right? So they're not the same. 2 and 1 not the same. So the limit of ls when s approaches 2 does not exist. So only C correct, right? Now let's move on to question 6. If the function ls equals 2s squared plus 1, then we need to find this limit, right? So this guy is the same thing as limit when s approaches 0. ls, I'm going to replace this one with 2s squared plus 1, right? And f of 0, substitute 0 for s over here, so it could be minus 1, right? Over s squared, right? So 1 minus 1 is going to be 0, so I'm going to end up with limit of 2s squared over s squared when s approaches 0, right? This guy cancel out, the answer is 2, right? The answer must be C. Now let's move on to question 7. If f prime of s equals cosine s and g prime of s equals 1 for all s, if f of 0 equals g of 0 equals 0, then we need to find this one, right? So, look, this is f of s, this is g of s, right? We don't have it, we need to find it, right? So we need to take entire derivative both sides, like that, right? So, you have f of s equals sine s plus c. So, we're going to use initial condition right here, right? To solve for c, right? So, we have f of 0 equals sine of 0 plus c, and this one actually 0 right here, right? So sine of 0 equals 0, so c equals 0. So then you have f of s equals sine s only, right? Now similarly, we're going to take entire derivative of this one, right? So we have g of s equals s plus c, right? And we use initial condition right here, right? So we have 0 plus c equals 0, right? Because g of 0 equals 0. So then c equals 0, right? And then you have g of s equals s only, right? So we have the limit right here equals limit when s approaches 0 of sine s over s. And this is the formula, actually 1, right? The answer must be B. Now we have another way to do this one. We can use the L'Hospital rule, right? So we have limit of f of s over g of s when s approaches 0. It's going to be limit of f prime of s over g prime of s when s approaches 0, right? And it's going to be f prime of 0 over g prime of 0, right? And f prime of 0, we have f prime of s equal cosine s, right? So it will be cosine of 0 over g prime of 0 equals 1, right? Right here. So cosine of 0 equals 1, so it will be 1 over 1, the answer must be 1, right? Now let's move on to question 8. Given the function f of s right here, let f be the function defined above. Which of the following statement about the function f true? Alright, limit of f of s when s approaches 2 minus equal limit of f of s when s approaches 2 plus. Alright, so we need to find limit of f of s when s approaches 2 minus, we're going to use this guy right here, right? So it could be limit of ln of 4s minus 7 when s approaches 2 minus, right? So we substitute over here, we have ln of 8 minus 7, and it's going to be ln of 1 is going to be 0, right? Limit of f of s when s approaches 2 plus, it's going to be this guy right here, right? So it could be limit of 4s minus 7 when s approaches 2 plus, and it's going to be 1, right? Now this guy and this guy are different, right? So the limit right here does not exist, right? So the answer is number 1 wrong. Now number 2, we're going to check the derivative of this one. So we have f prime of s equals derivative of ln u. It's going to be u prime over u, right? Where u equals 4s minus 7, right? So it could be 4 over 4s minus 7 for s less than 2. And the bottom one right here is going to be 4 for s greater than or equal to 2, right? So we need to find the limit of f prime of s when s approaches 2 minus, we're going to pick this guy right here, right? So it could be limit of 4 over 4s minus 7 when s approaches 2 minus, right? So it could be 4 over 1 is going to be 4, right? Limit of f prime of s when s approaches 2 plus is going to be limit of for when s approaches 2 plus, right, which is the bottom right here, and it's going to be 4, right? The left and the right the same, right? So number 2 is right? The function f is differentiable as s equal to, this is not quite correct, because the function is not continuous as s equal to, right? Number 1 is wrong. So remember, if the function is not continuous at a point, it will not be differentiable at that point, right? So only 2 correct, which is B. Now let's move on to question 9. If the limit of the function f(s) when s approaches a equals L, where L is a real number, which of the following must be true? Alright, so for example, I'm going to let the function f(s) equals 3, right? And I'm going to sketch this one. So f(s) equals 3 is right here. Suppose the function f(s) has a hole right here, right? And the x-coordinate of the hole right here should be a, right? So the function is not differentiable at this point because it has a hole a strong. The function f(s) is not continuous at this point, this strong. The function f(s) is not defined at this point, right? This strong. f(a) is not equal L, right? Because only limit, right? So this one wrong. So the answer must be E. Now let's move on to question 10. For x greater than or equal to 0, the horizontal line y equal to is an asymptote for the graph of the function f. Which of the following statement must be true? Just get the graph, you will see it. So y equal to is going to be right here. This is a horizontal asymptote. Alright, so suppose I have the rational function, it could be something like this. Now, f of 0 equals 2. It's not correct, right? Question B. f(s) different from 2 for all s greater than or equal to 0. It's not correct, right? Question C. f of 2 is undefined. It's not necessarily true, right? Question D. Limit of the function f(s) when s approaches 2 is equal to infinity. No. Limit of f(s) when s approaches infinity. Yes, infinity right here. Equals to, right? This is horizontal asymptote, right? The answer must be E. Now let's move on to question 11. If the graph of y equal ax plus b over s plus c has a horizontal asymptote y equals 2 and a vertical asymptote s equals -3, we need to find the sum of a plus c. Alright, you know that the horizontal asymptote is the ratio of the leading coefficient of the numerator and denominator, right? So leading coefficient right here is 1, this is a, right? So you have a over 1 equals 2, and then a equals 2, right? Now we need to solve for c. We have the vertical asymptote right here, s equals -3. So we need to convert this one to factor, right? So s equals -3. Add 3 both sides of s plus 3 equals 0, right? So this one is the factor, and you have the factor right here, s plus c, right? So we put s plus c right here. We just match this guy up, right? So c equals 3, right? And a equals 2. We add this guy up, it's going to be 5. The answer must be E. Now let's move on to question 12. We need to find the limit of this function when s approaches infinity. We can use the relative growth rate. When s approaches infinity, 2s grows faster than this one. We can ignore the constant right here, right? We can ignore 3 right here. We can ignore this guy, and we can ignore this guy, right? So it's going to be limit of 2s times negative s, going to be negative 2s squared. The bottom s times s going to be s squared, right? When s approaches infinity, this guy cancel out. The answer is -2. The answer must be B. Now let's move on to question 13. Given the function f(s), now question 1 right here, the function f has a limit as equals 2, right? So limit, which means we're going to pick this one right here, right? So we need to find limit of the function f of s when s approaches 2. It's going to be limit of s squared minus 4 over s minus 2 when s approaches 2, right? And it's going to be limit when s approaches 2. Factor the numerator is going to be s minus 2 times s plus 2 over s minus 2, right? This guy cancel out. Substitute 2 for s, it could be 4, right? So, number 1, correct. Now, number 2, the function f is continuous at s equals 2. Now, in order for the function f to be continuous at s equals 2, we need the limit right here must be the same thing as f of 2, right? So f of 2, we're going to use the bottom one right here equals 1, right? This guy and this guy different. Number 2 is wrong, right? Now, number 2 is wrong, number 3 must be wrong. Because the function is not continuous, it's not going to be differentiable, right? So number 3 automatically wrong. So the answer must be A. Now let's move on to question number 14. Let f be the function given above. What are all values of a and b for which the function f is differentiable at s equals 2? Now, in order for the function to be differentiable, it must be continuous first, right? So, we need to find limit of the function f of s when s approaches 2 minus, right? It's going to be this guy right here. So, substitute 2 for s. So, it's going to be limit of s plus 2b when s approaches 2 minus, and it's going to be 2 plus 2b, right? Now, limit of the function f of s when s approaches 2 plus, we're going to use this one. So, it's going to be limit of a s squared when s approaches 2 plus, substitute 2 for s, it could be 4a, right? So, we need the function to be continuous first, right? So, the function continuous, then we have 2 plus 2b equals 4a, leave it over there, right? We need the function to be differentiable at s equals 2. We need to take derivative of this one. So, f prime of s equals 1 if s less than or equal to 2. Be 2as if s greater than 2, right? So in order for the function to be differentiable at s equals 2, we need limit of the function f prime of s when s approaches 2 minus equals limit of the function f prime of s when s approaches 2 plus, right? So it's going to be 1 equals 2as, right? But s equals 2, so we have 2a times 2. It's going to be 4a, right? So a equals 1 over 4, right? Substitute 1 over 4 over here. So we have 2 plus 2b equals 4 times 1 over 4 is going to be 1, right? So b equals negative 1 over 2, right? So the answer must be A. Now question 15. If the function f is continuous for all real numbers, and if f of s equals this one when s not equal to 2, then f of negative 2 equals. Now remember, if the function f of s is continuous, we have limit of the function f of s when s approaches c must be equal to f of c, right? Now we need to find the limit of this one. So limit of f of s when s approaches negative 2, right, equals limit of s squared minus 4 over s plus 2 when s approaches negative 2, right? So we factor the numerator, it's going to be limit when s approaches negative 2 of s minus 2 times s plus 2 over s plus 2, right? We cancel out, right? Substitute negative 2 for s, it could be negative 4, right? And then it's going to be f of negative 2. So the answer right here must be negative 4, right? The answer must be A. Now, number 16. The graph of the function f is shown above. At which value of s is the function f of s continuous but not differentiable, right? So the function is continuous but not differentiable. Look at this one, the sharp turn right here. Whenever we see the sharp turn, the function is not differentiable, right? But the function is continuous as equal a, right? So the answer must be a right here. Now let's move on to question 17. For which of the following does the limit of ls when s approaches 4 exist? Right? So we look at the function right here, 4 here, 4 here, and 4 here, right? So we need limit of the function ls when s approaches 4 minus equals limit of the function f of s when s approaches 4 plus, right? So this one right here, 4 minus 4 plus, you have the same values right here. It's going to be 3, right? This one, same thing, same values, 4, right? 4 minus equals 4, right? And 4 plus equals 2, right? They are different, right? So number 3 is not the right answer, right? Only 1 and 2 correct, right? So the answer must be D. Now, number 18, limit of ln(s) minus 1 over s minus e when s approaches e is what, right? We substitute over here, we have limit of ln s minus 1 when s approaches e equals ln e minus 1 is going to be 1 minus 1 is going to be 0. Limit of s minus e when s approaches e equals 0, right? So we have indeterminate form, right? So the last L'Hospital rule apply. So now we're going to check the derivative of the numerator and denominator, right? So we have limit when s approaches e. ln s is going to be 1 over s. Derivative of 1 is going to be 0. Divided by 1, right? Substitute e for s, so it will be 1 over e, right? So the answer must be A. Now let's move on to question 19. The graphs of the function f and g shown above. The value of the limit of f of g of s when s approaches 1. Alright, so this one is the limit of composite function, right? So it's going to be the same thing as f of limit of g of s when s approaches 1, right? So look at the function g right here. When s approaches 1, you get 2 right here, right? So it will be f of 2. Look at the left ones right here. F of 2 equals 3, right? So the answer must be C. Now let's move on to question 20. Let f be a function defined by this one. Show that the function f is continuous as s were 0, right? So remember, we have a formula. The function f of s is continuous as s were 0. We need limit of the function f of s when s approaches 0 minus equals limit of the function f of s when s approaches 0 plus equals f of 0, right? So keep that in mind. Now we need to do this one step by step, right? So we need limit of the function f of s when s approaches 0 minus, we're gonna pick this guy right here, right? So it could be limit of 1 minus 2 sine s when s approaches 0 minus, right? So substitute 0 for s, it could be 1 minus 0, it could be 1, right? Now limit of the function f of s when s approaches 0 plus, it could be limit of e to the negative 4s when s approaches 0 plus, substitute 0 for s, it could be e power of 0, it could be 1, right? Now the last one, f of 0, we're going to use this one right here, right? So it could be 1 minus sine 0, right? Don't forget 2 right here. So it could be 1, right? So we can conclude that sin limit of the function f of s when s approaches 0 minus equals limit of the function f of s when s approaches 0 plus equal f of 0. The function f of s is continuous as s were 0. Now question 21. The function f is defined by this one. Let g be the function defined by this guy. Is the function g continuous as equal -3? Use the definition of continuity to explain the answer. So again, in order for this one to be continuous, you need limit of the function g of s when s approaches -3 minus equals limit of the function g of s when s approaches -3 plus equals g of -3, right? Now, step number 1, we need to find limit of the function g of s when s approaches -3 minus, right? So -3 minus, we're gonna pick this guy right here, right? So it's gonna be the function f of s right here, right? So it's gonna be limit of the function f of s when s approaches -3 minus, right? So it's gonna be this guy right here, right? So it's gonna be limit of square root of 25 minus s squared when s approaches -3 minus, right? Substitute -3 for s, the answer is square root of 25 minus 9. It's going to be square root of 16 and it's going to be 4, right? Now, limit of the function g of s when s approaches -3 plus. So we're going to pick this guy right here, right? So it could be limit of s plus 7 when s approaches -3 plus, and it's going to be substitute -3 for s, it could be 4, right? Now we need to check g of -3, right? So g of -3, we're going to use this one, right? So it could be f of -3, right? So it's going to be square root of 25 minus -3 squared, right? And it's going to be 4, right? So this condition right here satisfied, right? So then the function is continuous. So you need to say the function g is continuous as equals 3. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her